Maybe live then. No recording of this.
I mean, like we can be live, and I can email it to you guys if you guys want to go over this again. But
No, I'm really okay. I think we're clever and funny.
we are. Okay, let's see here. The collector does on 100 students. The sample mean was 21. Standard deviation 2.61. Next are given below. The group noticed an error in the data. The age of one of the males was entirely incorrect. He was actually 21 years old. When it is corrected, what will happen to the sample median? The median will increase.
Yep. Wait, hold on. The median's the
Doesn't
number
the
in the middle.
median stay the same, I believe?
Let's see. The median.
Yep. Yes. All right. So write out the number.
But the median stays the same.
18.
Why would the median stay the same?
Because the median is when you lay out all the numbers.
You're right. Yeah, you're right. So because he's older than the median, and so it'll just jump from one side to the other. And yeah, okay.
Well, 18.
I think we got that wrong on our quiz when we took it originally.
Hold on, 21. Crap, I hate being dumb. Sorry, I'm really tired.
You're good.
Okay. 12, 18, 20, 21, 20. So I just ran them out. And the median will increase because it'll go from 20 to 21.
Ha! I'd actually be able to. I'd actually buy that it is not possible to determine without the full set of data.
Oh, I'm with you on that one too. Never mind. Because n equals 100. I was like, oh, with the 5 data sets, like this is what happens.
I agree with you, Mark, on that one. I'll go with that one.
Yeah, Charlie.
It's not possible to determine.
Yeah.
Yeah, because you have to lay out all the data.
Yeah, well, because the median is going to be the 50th data, the 50th piece of data. And we don't know where that is. And so it kind of depends if this guy's age, this guy's age who moved from 3 to 21. It depends on which side of that median he falls on.
Yeah.
Okay.
Right.
Right. Yep. No. Okay.
Because if he stays on the lower side of the median, then it doesn't matter. But if he's above it, then it does.
Yeah.
Okay.
Number 5, normal mean was 70 minutes and a standard deviation of 10 minutes. Using the rule, approximately what percentage of students will complete the exam in under 50 minutes? So that would be 2 standard deviations, so it would be 95%.
Wait, hold on.
I'm pretty sure the answer to this is 16% because I looked it up on an old.
What?
16% is what I have. Like if you go back to your lesson 5, but I have no idea how to get that answer.
Wait, hold on. Okay, so let me read it real quick, and I'll double check something. Because I was just like playing along, like, yeah, sure, that sounds great, guys. Because I was trusting you. Okay. Oh, it should be to the left.
Yeah, it should be 68, correct?
I believe 95 because it's 2 standard deviations.
Yeah,
It shouldn't be 95 because you're completing the exam in under 50 minutes, which is less than the mean.
It may
So
be 0.5.
It should be a relatively small number.
It should be 5%, guys. Here.
5%?
Yeah, because So 70% of the people are going to be basically between 99.7%. So 0.3% of those are not going to finish it, are going to finish it longer than 70 minutes. Then the next one we go down to, one standard deviation will be 60. The next standard deviation will be 50. It's 5% because we go from
Listen
3%.
to this. If you go to your, I'm going to read you from lesson 5 homework, number 9. It's the exact same information. The time to complete a standardized exam in the BYU Idaho Testing Center is approximately normal with a mean of 70 minutes and a standard deviation of 10 minutes. Using the 68, 95, 97.9, whatever rule, approximately what percent of students will complete the exam in less than 1 hour? So that's different. Like they're asking 50 minutes. This question is asking an hour. But the answer to that they give us is 16%.
Is 16%?
16%.
There's no way that makes any sense. I would love to see there. Did they give any explanation of that at all, Becky?
That's what I'm looking.
Wait, hold
No.
on. There's no, of course there's no explanation.
Unless I'm totally...
Okay, so hold on. So 1 deviation is 99.7%, correct?
Yeah.
And that put us at 60. Okay. The second one would take us, so 95% going to be doing it within 2 standard deviations. So that's going to give us the 50. And so, but outside of that range, so under 50 minutes means that it's going to take them more than, going to be shorter, which is going to
Hey,
cut down.
Becky, do you know where that comes from? I just did it. So you take your z-score, which is x minus u, so 60 minus 70 over a standard deviation of 10, which left us using the probability applet of 0.16, 16%. And so this one, let's just do...
Would be the z-score for this comes out as
50
negative.
minus 70.
But guys,
by...
you're missing a key point, which is using the 68, 95, 99% rule, which is it's an approximation. We're not actually solving it. So it'd be the 0.05,
Yeah.
but we round that to 1 decimal place, would be 0.1. So we're not actually going through the z-score.
Yeah.
Because they're asking us to use the rule to approximate where it should be.
Okay.
Does that make sense?
Yeah.
What I just said? If I am wrong, you guys can really just mock me for this for hours.
Wait, what are you saying the answer is, Sarah?
So, because it'd be outside of the second deviation, it'd be within the second deviation, it'd be 0.05 ideally. Theoretically, it'd be in that range. But we're supposed to give it to 1 decimal place. So instead of 0.05, it'd be 0.1. This 0.05 rounds up to 0.1. Does that make sense?
The actual answer is 0.02. I know we're estimating using the rule, but
wait, where's 0.02 at?
Yeah.
That's on the normal probability applet.
Oh,
Right.
You're right. Those dirty little rats.
And we're supposed to give it as a percentage as well.
Yeah. So it'd be 0.0.
0.022. So is it 2.3%? 2.3%?
We round to 1 decimal place. So are we supposed to round it to? Well, the example is 24. Okay, so is it 2.0%?
So the answer is 0.0228 or 2.3%.
Okay, 2.3. Okay, that makes sense. I hate percentages, especially with how they did this, because it's really confusing as whether or not we're supposed to do like 5% as 0.05 or 5% as a 5.
But that's not really
Here's
using
the question. Now here's the question though. If they're wanting us to just use the 68, 95, 90, 99.7 rule,
Oh,
does that mean that our answer should be 3?
he said it should be 3.
How do you even figure that
2.5.
out using that rule?
Yep. It'd be 2.5, which puts it 3.0. Good catch, Mark.
There's also every possibility that we've totally overthought this.
There is also that.
How do you do this using that rule?
So
It's not 95 because that includes 50
Yes.
and above clear up to 90.
okay, so Becky, I want you to pick.
So we're using. Go ahead, Sarah.
No. You go ahead, Mark. I talk enough. You handle this.
Basically, we know that we're only looking at one side of the. Since we know that we're only looking at one side of it under 50 minutes. We know that we're using half of the remaining percent. So half of 5%, which is 2 standard deviations, is 95%. So we're only using half of that, which is 2.5%.
Okay, so should that not be our answer?
Oh, you're right. It should.
Oh gosh, that's funny. So 2.5, not 3.0. Sorry. Sorry. Well
my
done,
bad.
everyone.
Which makes more sense because the true answer is 2.3, so 2.5 is much closer than
3.
where we're approximating.
Yeah.
As Mark would say, I'll buy that for $1.
I think we should take the test as a group.
Meet you here at
You
4
I
o'clock.
don't think
I think
anything could go wrong with that. I don't see a downside whatsoever.
Oh, we have LSAT question coming. It's like one of their favorite ones to ask us.
All right, we're on number 6 of 47, and we've been on here for how long? Hang on.
Don't even tell us.
Go, Sarah, go. LSAT us away.
Wait. Oh, I love LSATiness so much. Okay, so the mu is 150.7. The standard deviation is 10.2. How charming. Then our x is 157. And we want the 35th percentile.
Okay.
Oh, blast. I hate them so much. I'm going to pull up notes from like the first thing. Okay. So I do remember it's 157 minus 150.7, correct?
Correct.
Divided by the standard deviation. That gives us the z-score.
Yep, that gives us a z-score. Then how do we figure out the 35th percentile?
Yeah.
I'm glad I'm not the only one that was stuck on this. I was feeling slow for a second.
Wait, hold on.
Well, hang on. Let's play with the numbers a little.
Okay, so if we go to our histogram and descriptive stats on quantitative descriptive statistics.
I think I get it.
Wait, hang on. I got it. So 0.35 in the area. So we're looking at a z-score of negative 0.385 equals minus 150.7 over 10.2. Correct?
I'm doing something here. 1 second.
Okay, so let me run through really quick, Mark, what you just did, which is we found the z-score for the 35th percentile, and the Queen's School of Business of Kingston crap is all just to screw with us. It's pointless.
Not quite all of it. We still need the deviation and the normal mean.
Yeah, but the 157 is just a red herring. Correct?
Yes, that is correct.
Okay.
So what did you do?
Correct.
Tell me again how you did it.
Mark, I'll let you explain.
So I just plugged in 35% into the normal probability applet and shaded the left side.
Oh,
So I got the z-score for the 35th percentile. Then I just plugged that into the equation and got negative 0.385 minus 150.7 over 10.2.
What did you end up getting?
You know, working on the math right now.
Okay.
I'm working on the maths right now.
Oh, dang it. Sons of guns that we love and adore. Pause. Is this quit exam 4? Is this also our, like, is this just for unit 4, or is it supposed to be the final exam?
I'm not sure.
This is the last exam, so I'm
Oh,
pretty
so
sure
is this
this
the
is it.
final? I was like, those flipping jerks. Like, why are they doing this for this week? Okay.
Yeah,
Never
looks
mind.
like we just had one exam.
so you put 0.35 into the normal, probably click left. That gives us a z-score of negative 0.38.
Click left first. Click left first, and then put 0.35 in. Is that Becky?
Yeah.
You click the left first, then you put the 0.35 in.
Okay.
Because
Which
otherwise
gives
you're getting 17th percentile.
0.637, right? Is that what you guys got? Something different?
Okay, so we're doing the 35th percentile, which means it'll be 35% of the data needs to be to the left of the second of the lower z-score. So you need to click the left, then put 0.35 in to the area.
In the area.
But click left first,
That's
then do.
the difference
Of the area.
negative 0.385.
Uh-huh.
Does that make sense, guys?
Yep, sorry.
I see what Margaret's throwing down, but I'm like, let me make sure that everyone else is. Dang it.
All right, the answer I got was 146.8.
That sounds right.
So then after you do that, what did you do with it? After you get your, that's all you're doing?
I just plugged it back in. I just plugged it back into the equation, and we're trying to find what the score is for the 35th percentile. And so you leave out the minimum score required for admission.
So you plug it back into what equation? Sorry, you have to be.
Oh, sorry. The z-score equation. So
Okay.
x bar minus mu over standard deviation of sigma.
Okay. Oh, I'm with you now. Okay, so we're finding x bar with the applet.
We're looking for the x, so we have to solve for the x from the equation, which brings us down to 146.8.
Oh, and then we switch it all around. Okay, I think I got it. Thanks.
Good job, Mark.
Yeah. So what was our final answer?
Hey guys, that's it. I'm tapped out.
Oh my gosh.
What was our final answer?
146.8
Okay.
of the cussing.
Okay, Matt.
A team of dermatological. Okay. Since Mark just bailed me out, I'll do the next one. A team of dermatological researchers studying skin cancer among 60 to 70-year-old men. Old men. Suppose you're a part of the research team, take a sample of men's group and calculate man's skin scat spots. Also, right skewed. It's gonna be skewed right. So alpha.
Yeah, if you're only going with, if
2.
you're only trying to get 2 dudes.
Yep. Then it's gonna be biased. They need more skin samples. Sorry. Evil Sarah. Evil Sarah. Okay.
Okay, number 8. After we read all of our information, I think what we do is just solve for our z-score using our x and our mu, x minus mu divided by standard deviation. gives us
Yep.
20 minus 855.44 divided by 12, which gives us negative 710.33433.
Oh yeah, the z-score is okay. Okay, that's integration divided by square root of 10. How do I have this memorized? This is silly. Silliness,
I was
tell you.
just thinking about that. It's really sad.
I on -4 by so you got negative 1.49071195. Right, Becky?
No.
What?
Okay, let me see.
Oh, you just get
it should be a
0.5?
positive number.
Isn't it 20 minus 8544 divided by 12?
It should be 8550 minus 8. Oh, I did that wrong. I put 8554 instead of 8544.
I got 10.
0.5.
What? I did 20 is our x, because we want to do it for 20 tanks. So I'm going with x minus mu divided by standard deviation.
No. So x 20 isn't x. 20 is n. So it's 8550. 8550
Oh wait, 20
minus.
needs to n needs to be square root, doesn't it?
Yeah, n needs to be square root. So it should be
There's the
8550.
problem.
8550 minus 8544 divided by 12, which is divided by the square root of 20. Which gives you 2.236. Oh my goodness. I do not like this.
Yeah, I got 2.236 as well.
Yep. Oh my gosh. I really feel like this final should be a group final. Holy crap.
Yeah. It's been a long semester.
Maybe this will be a thing where they get really excited and like, you know what, we realize that we're being funny, so what we're doing is this group meeting is really secretly your final. We're just not telling you until after it's done. That'd be amazing.
Tell me that number again. Sorry, guys. That was hard for me to follow.
2.236.
Yep, 2.236. Nice work.
Is that what you got, Mac, or are you still getting 0.5?
No, that's what I got. That's what I got. I was just doing. I was not doing the end. So as soon as I realized my error, that's what I got. Yep.
The error of your ways.
The sins of my ancestors.
Oh gosh. Okay. Oh, hey! I accidentally solved the next one. Completely. Oh no, I lied. Did not. Okay. I'm just kidding.
So I think we just do the same thing, but put our n as 50, and then plug that in to the normal probability, right?
Yep. What? It's craziness, to tell you. Craziness. Wow, that sucks.
All right, let's see your greater than. It's gonna be really, really high.
Yes, it is. Ugh.
It's
2, 3, 5, 7, 3. Yeah, it's gonna be like 90.
All right, 99.08%.
So 0.991. Right?
Yeah.
Does that make sense, everyone?
Yes, thank goodness.
Sorry, I shouldn't laugh that much. All of us. Sorry. I feel like, I don't know. I have my feelings about this. Really good. Okay.
All right, guys, we're coming up on a quarter of the way done.
And don't we all feel so confident about this final?
Oh,
All right, are we ready to move on to 10? Does everybody get how we got 9?
yep.
We're good.
Cool. Which one of these best describes the notion of the significance level of a hypothesis test? The first one is the p-value. It's the probability of a type 1 error. Is that right?
Yes. Yes.
I believe so, yeah.
Cool.
Well done. Well done.
I exuded confidence.
Okay. right, Mac.
I'll take 11 here. The height of young adult females in the United States are said to have a population standard deviation of 2.6 inches. A sample was taken of 85 young adult females at BYUI, and the mean was computed to be 65.4 inches. Which of the following explanations describe the correct way to interpret the 95% confidence interval for this problem? I'm going to go Charlie there. Approximately 95% of all 95% confidence intervals.
Yes.
Wouldn't echo also be correct?
I'm checking.
Except for his anything with chance in it is automatically wrong.
Right?
Yeah, I think it's Echo. I think he's right on Echo, too. I think
Well, but
it's Charlie and Echo.
It's one of the ones. This is one of the ones where we can select multiple. So
Yeah, it's Charlie and Echo. I'm pretty sure you're right.
Okay.
Not
But,
that I know.
95% chance that the true mean.
Because their sample size is over 30. So
Isn't there either a 100% chance or a 0% chance?
Yeah, you're looking at Delta. It's the next one down. Down. Echo.
Oh. Huh.
I got you. I'm following you.
Yep. Yeah, I'd agree with that. Yeah. Sorry, I was looking at Delta.
Yeah, you're
very
fine.
good.
Once you start, I'm like, no, I know what hang up is. You're looking at one more down. Oh my gosh, 2.236. Sorry, I'm taking a moment to go back through all of our stuff and just write down the answers now, so that if we need to go back and fix something, we're not having to be there forever.
Oh, that's good. I appreciate that you're doing that.
I do that. I was like, oh, pause. Well, we're only 11 in. Let me get this done. Okay, now we're on 12. Where are you, 12, you little son of a rascal? All right. Marine biologists have been studying the effects of acidification of the oceans on weights of male beluga whales in the Arctic Ocean.
I remember this study.
One of the studies involved a random sample of 16 beluga whales. The researchers wanted to create a 95% confidence interval to instrument the true meaning of the male beluga. The data follow a normal distribution. The population standard deviation of weight is male beluga, blah, blah, blah. This standard deviation is their confidence interval. What is the requirements? Yes. Because their stuff came out normal. Because their data are normal. Beta.
Yeah.
Thank you. Beluga? Beluga's a fun word to say. Okay, moving on.
Beluga.
Yes, the distribution because the data are normal. Okay. An investor with a stock portfolio with several $100,000 sued his broker and brokerage firm because he felt the lack of diversification in his portfolio led to poor performance for many years in a row. In an effort to avoid close public scrutiny, the firm agreed to settle the conflict by an arbitration panel. The arbitration panel compared a sample of 39 months of the investor's return to the average of the Standard & Poor's 500 stock index for the same period in order to determine whether there was a substantial decrease. Data are recorded, blah, blah, blah.
This is a one sample
0.95.
two test, right?
One sample two test.
Let's see. We don't. I think it's a t-test, isn't it?
Yeah, one sample t-test.
Yeah.
Yeah.
Okay.
One sample t-test. And
Oh, I mean, Goober. Goober,
the
Goober.
answer is 1.
Delete.
And by
What the null? Do we change the null hypothesis by chance?
we should. It should be 0.95.
That's the
Rates of return. I can go that one because return. Monkey, cows, and bologna sandwiches. Okay.
Significantly worse. So it should be less than.
less than.
Uh-huh.
Still get okay. So then our p-value is 0.0000. We change it to less
Did you
than.
change the null hypothesis yet? It should be the null hypothesis should be less than 0.95.
0.95 or 0.0?
0.95.
0.95.
0.95? Wait, what am I making here?
Confidence
Hold on.
level should be 0.95, right? And the null hypothesis is 0.95 as
Yeah,
well.
it should. And the null, it says the S&P has a known population mean return of 0.95, and we're trying to figure out if the investors' portfolios perform significantly worse than the performance of the S&P 500.
Okay. So 0.95. So
Yeah,
you're doing
so the
0.95 confidence. We're doing
Yeah,
95.
the confidence interval and null hypothesis are both 0.95.
Oh, good. That doesn't make anybody confused at all, right?
I know, right?
Okay. What are the p-value? So 0.019.
Yes.
Yeah.
I feel like I read that really slowly. 0.019. Anyone? Okay, we're done. I don't know why I thought that was kind of weird. Okay, 0.019. Okay, and this is
All right. A financial economist is studying. Oh, went too far.
got it.
Studying married couples, which both spouses work. He wants to compare the mean income earned by husbands and the mean income earned by wives. Should he use independent sampling or dependent sampling? Now this one's tricky. If I remember right from the last time.
Oh, dependent, right? Yeah, dependent, because the husbands are selected from the wives, or yeah, so the husbands are selected from their wives. So if you pick the wife, you pick the husband. It's dependent.
Yeah. Okay. So bravo.
Yeah, bravo.
That's what I have. That sounds good.
Cool.
Pressures of supply and demand act directly on the price of airline tickets. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, the airline may discount tickets or even cancel the flight. Allie, a BYU student, wanted to determine if there is a difference in the price. Ticket listed 90 days before the flight compared to 14 days before the same flight. For her study, she compared the price. Well, we have that data. I'm not going to finish reading it.
Quick, everyone, make him keep reading. Make him keep reading. No, I'm just kidding.
All right. Let's see here. This one.
So this one we're doing a paired sample.
Yeah, it's paired. That's great. Okay. And 14 goes first, right? Goes in the first column, correct?
That I don't know.
I think it does.
Well, we're finding the difference between 90 to 14. So I think the 14 is subtracted from the 90. So we put 90 first is what my thought is.
Okay,
Maybe.
that sounds right. That feels right.
Feels right to your soul.
Yes. So 90 goes first, then the 14.
Yeah.
Okay, so let's look at the 90 versus the 14. Please tell me they did this normal. Otherwise, I'm going to be swearing slightly. No, of course. Okay. Yeah, we like to complicate our lives. Jerks. Okay.
All right, so I got 0.96. Is that right?
Oh.
0.96.
0.096, right?
You guys are speedy demons.
You know, I've had this cough for 4 weeks now. I should probably go see a doctor.
Yeah, I'd recommend it. Are you hacking crap up yet?
You know, not like anything troubling.
I'm not dead yet.
No blood or chunks of lung or anything like that. So
Oh, what type of test are we doing? Real side note. Are we
Not
doing
equal to.
not equal? Is it not equal to? Well, I know it's a paired sample. Let me double check this really quick.
I think it's not equal to, because we're not necessarily looking to see if it's less. It's just if there's a difference.
Yep. Okay. Yeah, not equal to. You're right. I was looking for that key little word. I'm like, let me quadruple check before we do this. P-value would be
0.095, 0.096.
Yes. That's what we got.
Okay, I've got p-value. Where'd you go? My p-value ran away. Yeah, 0.96, right? That's what we just said?
0.96, yeah.
right.
Yep.
0.096. Okay.
Hey. Wait, I missed something. Okay, on. 15.
I'll be right back. It's cold in here. I need to turn the heater on.
Fair enough.
All right. I got alpha for the next one.
Yep.
Yep.
I think I remember missing this one on our last quiz, number 17.
It should be Charlie, I do believe. Because I think we missed it because we said there wasn't enough N samples. But the data is normal. That was our problem.
Because the QQ plot follows normal.
Yep. We all thought, yeah. So that one is Charlie, correct? Yeah.
$30 more.
We're almost halfway
Right.
there,
Almost there.
guys. Quarter way there. Quarter. Okay. This one should be Charlie as well,
Is that
because it's a difference question. So the idea is that the difference should be the same, so it should be the UD.
Cool.
It's all yours, Becky. Oh, Becky's left. I made it. Becky,
Where'd
where are
Becky
you?
go?
Becky's gone.
She got translated.
Oh. Are you? You're still writing the answers down, right, Sarah?
Yes. Becky, how many did you miss?
I have 15.
Oh, okay, 16 and 1 6.
Yeah.
Okay. So 16 is Alpha,
Okay.
17 is Charlie, 18 is Charlie.
Okay. Thanks. Okay. My turn?
Yeah.
Okay. Suppose you create a 95% confidence interval for a mean and get that. We've been told to report this by saying we are 95% confident that the true mean is between this and that. Exactly what does this mean? 95% of all 95 confidence intervals actually contain the true mean.
Nice.
Is that right?
Yep, that's right. Good old beta strikes again.
If p is 4/5, what is the smallest value of n that satisfies the requirements for normal distributed p hat?
I remember.
See here. And p. So it's n times 4/5 and n times 1/5. Equals 10. So.
Hey guys, you still there?
Yeah.
Can somebody see something in real quick?
There you go, Sarah.
Good. Okay. Yeah. No, my husband tried. My husband just tried calling me, and so I'm like, "Wait, guys, no!"
We're here still. So the solve for n, we do z over m squared, right?
What?
Times p. No.
No. So this should be the NP.
It should be n times p and n times 1 minus p, and they both need to be over 10.
Yeah. So whatever the smallest number is between those two. Forgive me, guys. I'm running through really quick and writing all the way to 47, so I can make sure I can write all this stuff down.
I got 50. Mark, did you get there yet?
Yeah, 50.
Yep.
50? 50?
50.
Correct.
Say that one more time how you did it, guys.
So this is
So
the
it's so you have two equations, and you need the bigger of the two numbers. So it's n
NP is greater than or equal to 10,
Yeah.
and n is.
It's n times p equals 10, and n times 1 minus p equals 10.
Okay, gotcha. Thanks.
Uh-huh.
Wait. It has to be the bigger of the two numbers.
Right.
Correct.
Which is 50.
So it's 50.
50? Okay, good. So I thought we said that would be the smaller of the two, and I was like, wait, no. Okay, we're not recording this, right?
No, we've been live this whole time, but we're not posting it anywhere.
Okay, so can I recommend that we just follow through the logical thing where one of us submits this thing so we don't have all four of us trying to rewrite the 47 questions?
Oh yeah, absolutely. That's absolutely what we're doing.
Okay, good. Okay, and so that's 50. Sorry. Like, I've got them written down, but gosh dang, it really sucks doing this. Okay.
I'm writing them down too, just in case.
What, Becky? You think I could possibly make a mistake? Who are you?
Because it really messes me up how they, just for me to go back and study.
Oh, you're fine. I'm joking.
Yeah.
I
trust you.
I think it's a good idea if two of us write them down, because then if one of us writes something funky, then we know what it is. Okay, and I have a really bad handwriting. Okay, 21. Who's up? Is it me?
I got it.
Yeah.
Your
Max.
brother has a batting average of .233. You want to determine the probability that he'll have a batting average of over .250 next season when he will be up to bat 40 times. Are the conditions met so that sample proportion will be approximately normal?
Oh, that's a good question.
Well, although B is true, as in beluga whale, if P is
Delta,
normal,
which one are we checking? Are we checking next year's or this year's?
Next year's. Next to the .250.
the .250,
Okay,
Uh-huh.
then it should be fine.
right? But does that, I mean, I know that's a requirement, but that requirement does not show that it's approximately normal. That just shows if it has to exist, correct?
Correct. So the thing is, so both of them. 0.33. What?
I'm kind of
Yes.
feeling,
I'm feeling
like,
beta.
233. Delta is correct.
Why is Delta correct?
Delta is a true statement.
Because we're checking.
What's that?
We're checking for next year, right? So we need to use the next year's batting average of 2.50.
Well, no, I mean the numbers in Delta are correct. Like 40 times .233 is less than 10.
Yeah, but I think we're using 0.25, so I think we should be okay with beta. Wait, but then the conditions aren't satisfied with just that one, so that can't be right.
right? I'm kind of thinking alpha because if, I mean,
Proportions, the n equals 30 has nothing to do with proportions. That's if we're doing, because proportion,
Oh.
it has to be the MP minus the MP 10 stuff.
Yeah, this doesn't make any sense because it has to satisfy both of those things, and there's no option.
Yeah, and so maybe they are supposed to be 0.233, so it's got to be delta because none of the other three make sense alone standing, if that makes sense.
Wait, why doesn't Bravo make sense? Why doesn't Bravo make sense by itself?
Because it needs to be, because we also need the MP minus 1. Although technically, I could see it making sense.
Since P is less than 0.5, minus 1 is going to be greater than P, and so it doesn't actually matter what P minus 1 is.
Okay, that's fair. I'm going to put Bravo, and then I'm going to put Delta in parentheses, because if Bravo is wrong, then it's going to be Delta.
Well, you definitely shouldn't take that statement. I'm just being stubborn.
Yeah, no, I think it is Bravo. You're right. Like, that's a valid point. And, like, logically, if that's going to be over 10, then 0.75 times 4 is definitely going to be over 10.
then the other one will
So, yeah, so I would say let's go Bravo, because that makes more sense based on what I'm understanding from this. But if it's wrong, I'll just put D in parentheses, so that if it's wrong, we know it's D, and we're just somehow misreading this awkwardly phrased question.
Okay.
Okay.
Cool.
Everyone. All right. Okay. Oh, I remember this one.
Who's up?
I think I am. It's Delta.
Just on that. Okay, researchers published a study in which they considered the incidence among the elderly of various mental health conditions such as dementia, bipolar disorder, obsessive compulsive disorder, delirium, and Alzheimer's disease. In the U.S., 45% of adults over 65 suffer from one or more of the conditions considered in the study. Calculate the probability that fewer than 320 out of the N equals 750 adults over 65 in this study suffer from one or more of the conditions of the consideration.
All right. Dude, I don't know how to do this.
It's you divide 320 by 750. We're gonna be 426 repeating. I think we plug this. Maybe I'm wrong. Let me look at it.
Since we're going with p hat equals x over n, so then we're doing 320 over 750.
One proportion z test for
P hat equals 320 over 750.
What is the null hypothesis really quick?
I think it's 0.45. Is that correct? Because that's what the U.S. study is.
Yeah,
that's what P is.
Yes. So you want to be using your categorical data analysis hat x blah blah blah, and you want to be putting this stuff into the one sample, one proportion test, the one proportion z test. So we got 320 over 750 with your confidence level of 95, and then we want less than, correct, as our test?
Correct, because we're doing fewer.
Got it. And what do we need? The p-value?
Sorry.
You're okay.
We just need the probability that.
So the p-value, which would be right. That's the p-value probability.
I believe so. Yes.
Okay.
0.099er.
Yeah, 0.099er.
Is that it? Okay.
Okay, wait, run me through my squares again. X of 320, N of 750, confidence level of what?
95. It doesn't really say, but just do 95%.
Okay.
It shouldn't change your p-value any, I don't think.
Yeah, I won't change it anyway.
0.45 is my null hypothesis and less than?
I'm still trying to open.
Oh.
Over here.
So then we get 0.099. Yeah?
Yep.
Yeah.
I feel as though this thing's 0.099. Do this over here.
$24 is Bravo.
Yep, Bravo.
Beluga baby.
Wait. Oh, no, it's not. That was dirty rats. That'd be less than. We're doing not equal to, so it's Charlie. It's double that. It's a two-tailed, not single-tailed. Yep.
Douchebags.
Yep.
Dirty.
Yep. The area to the right.
Split that into the normal probability applet, yeah?
No, you don't need to.
The 0.091 is the p-value, but it, as Sarah caught, it's only to the right, and since we're doing not equals, you just double it.
Yep.
4.182.
They what do you call it? You could put it in the probability app, Becky.
Mhm.
And just highlight both sides. But what they described is they'd only highlight one side, so you could do it that way, but you don't need to. You just need to double it because they're a bunch of dirty rats.
Let's see here. I got whatever the last one is for 25.
20. Last one's 25. Charlie.
There's more than 3 in there.
Oh, 25.
Any N will do.
Yep.
So what was your, any N will do? That's not your answer.
Yeah. It is because it's known to be normally distributed, I think. Hold on. Are we looking for a proportion?
Common knowledge that Cocker Spaniels have whatever it is. Let's see, what is it?
That's normal. It's really any N will do. Okay.
Yeah, it's common knowledge that Cocker Spaniels have normal fertility levels.
I knew that.
Does anyone else have a terrible moment where they think it's funny they're using a Cocker Spaniel for this?
No, I don't know enough about dogs.
That's the first thing they teach you when you walk through the doors of school.
Okay. But it's not a proportion, right? So we don't need to worry about the MP stuff.
Right.
Yeah.
Yeah, okay, this is normal quantitative happiness. Okay. The
It
end.
doesn't have to be greater than 30. When is it that N has to be greater than 30?
That's if it's not known to be normally
Okay. So it's either
Yeah.
one or the other.
yeah. If it's the only time we use the N minus P stuff is when it's a proportion.
Yeah. But if we're talking about if it's normally distributed, then we don't need a large sample size. And if we have a large sample size, it doesn't need to be normally distributed.
Correct. Yep. Thanks to central limit theorem and the law of large number.
Yeah.
Okay.
26, I'll take it. A study is planned to compare the proportion of men who dislike anchovies with the proportion of women who dislike anchovies. The study seeks to determine if the proportion of men and women who dislike anchovies is different. A sample of 41 men is taken, and the p-hat estimate for the true proportion of men who dislike anchovies was 0.67. A sample of 56 women were also taken, and the p-hat estimate for the true proportion of women who dislike anchovies was determined to be 0.84. Are the requirements satisfied to perform this hypothesis test?
I'll just say NP minus 1 crap for everyone.
Yep. So we're going to be doing...
Okay.
Let's see here.
I hate them so much. Okay.
0.67 times 41 is greater. And then obviously 0.84 times 56 is greater.
Okay, and now let's do the other side, though. That's going to be tricky ones.
Yep.
56 women we're doing?
Both of them.
Both, yeah.
So,
That should be good.
let's try the under side. So 0.16, clear. 0.16 times, what is that, 56?
41. 0.67 times 41.
Yes, no, I'm talking about for the n minus, n times 1 minus p for the 56 would be 0.16.
Yeah, so
That's
so it's the A, B, C, delta here. No, because
8.96, yep, that one's less. That was the one I'm like, this one's going to be a less number, so it's most likely not going to work. Yep.
So. Delta because it's less than 10.
Yep. Delta, delta, delta.
Well, it's going to get noisy in here for 1 second, but I will shoo the little children away. Early out day today.
You're okay. I got it. I got mine put down for a nap, which is why I was 4 minutes late to the meeting. Just like, she's down.
You're up, Sarah, 27.
I'm just reading it really quick. Difference. Okay, so it's going to be alpha. I mean, beta, Bravo, banana, bacon,
Beluga.
Beluga. Yeah.
beluga.
When mu of d does not equal 0,
Can you say Charlie on that one?
then beluga.
What?
On 27 beluga, right?
Correct.
Okay.
Excellent.
28. Weight Watchers wanted to predict how much weight a client would lose if they followed the prescribed exercise plan into their diet program. Me too. Volunteers were randomly divided into two groups. One group dieted but didn't exercise. The other group dieted and followed the exercise program. For the exercise group, they used linear regression with percent compliance with the exercise program. Monetary variable and pounds dropped in 3 months as the response variable. So X is blah, blah. One of the scientists told that his residual was 5.5 pounds. What does this mean?
Whatever you tell
I have no idea. So anybody?
Becky, I'm having a hard time hearing you, friend.
Hang on.
What's that? I don't remember saying anything what the residual means at all.
That's stand up there. A residual is the difference between the observed value of y for a given x and the predicted value of y on the regression line for the same x. It can be expressed as y minus y.
So let's see, our X,
Oh,
our X is the exercise program.
oh, okay. So y minus
Y,
ah. So it'd be
right?
observed value y and predicted is y. Oh, so he didn't lose 5 points. He was expected to be lower.
B, I
Makes
think.
sense.
Is that right?
Yeah, I'm sorry, I just pulled that up. I think it's supposed to be lower. I think it's yeah, was 5.5. This is really, really confusing. But basically, he weighs 5.5 more pounds than he predicted to weigh. So is that beta? Is that the best way to weigh it? Beta.
Wait, he weighs more, or he lost more?
He weighs more.
Yeah, if
Okay,
his
then it would
residual
be-
is
that'd
5
be
point.
alpha.
Is it alpha? This is this weird.
That'd be alpha, yeah.
It's alpha.
Well, isn't residual observed
Yeah,
minus
Nope.
expected?
Yeah,
So if it's higher than what's expected, is it B?
Wait, so residual is observed minus?
Yeah, observed minus predicted.
Okay, and it's a positive. It's a positive value, which means that his observed was higher.
Yes, so his
Mhm.
actual weight loss to what was actually observed was higher than what was
Which means that
predicted.
it's
So yeah,
Oh,
Bravo.
B.
beta.
Which means that Bravo.
Yep. Hello, confusing world of silliness.
Yeah.
Why is 6.5 pounds fatter than those last three?
Yeah.
I hate statistics.
I don't think it's statistics. I think it's just how they word things. We hate how this class is worded. That's how I put it.
Let's see here. For the previous study, for the previous question, the D1 of the regression line was 5 pounds. In terms
Or whatever you want me to do. You let me know.
B1 is the slope.
Yeah.
So let's see here.
So
Um, what's the X value?
So B1 would be Charlie, because as the percent compliance goes up by 1, on average 5 pounds are lost. So as you go up, it'll be,
Well, yeah, okay, I guess.
yeah, Charlie.
Let me go read the previous question real quick.
That's so jerks. Messing with us. They're such punks.
Oh,
Yeah, I would go with Charlie just because it's the only one that makes sense with a slope. The slope is
well, it is Charlie.
it's a percent, but yeah.
Yep, I got
Well,
you.
yeah,
I got
because
you back.
percent they stated in the last question that percent compliance is the X value.
Mm.
Trying to.
All right, creating a scatter plot or residual plot. Okay.
I'm just gonna drop.
All right, so first off, there's a linear relationship. We need constant variances, error terms known.
So is it BC, is it Charlie Delta Echo? Is that what I just heard? Matt?
Yes. Yep.
Okay.
I believe
Say
so.
again?
I'm just checking back in the book here.
Okay.
Let's see.
Go
The
ahead.
five requirements is there's a linear relationship. The error term is normally distributed. Okay.
Yeah, it
Handy
should
little table.
be and D or B, D and E.
The variance of the error term is constant for all values of x. The x's are fixed and measured without error, so we need to get that one in there too. That would be A.
So it says that x's are known as constants, and observations are independent are the only two that aren't solved with scatter plots and QQ plots.
All right. So what are the two that aren't?
A and C.
X's are known constants, and the observations are independent.
So we want beta delta
Well,
echo.
beta makes sense. Beta makes sense because QQ plots check for normal distribution.
Yeah. No, I'm just making sure. Beta delta echo, right?
Yeah.
Okay.
Oh, yeah.
Okay. Good.
Not A or C. Not Alpha or Charlie.
Correct. Yep.
Hang on. Why is Echo correct and Alpha isn't?
We can't
So
tell
is it
if X values are measured without error or not.
Oh, so it's just beta delta then, no echo.
Well,
Just two.
one of the things that can't be checked with a scatter plot or QQ plot is that X's are constants.
Yeah, so it'd be beta and delta, correct?
We can check. No, I'm pretty sure it's beta delta echo. I've got my graph out here, my chart from the homework, and it says the three things that we can check is there's a linear relationship between X and Y. That's delta. The error term is normally distributed. QQ plot of the residuals. So that would be the residuals are normally distributed.
All right, so we can look for the variance of the error term, but we can't look at the constant. So we're just looking at the variance. So that makes sense.
Yeah, we can't tell if their measurements are true or not. We can see how they plotted them, but we can't see if their measurements are
So we can see the variance. So it is theta delta echo.
yeah.
Okay, so all right, so Bravo Delta Echo.
Yeah.
Cool.
Oh my.
Oh, I'm really glad I didn't close that. I was thinking about closing it.
Oh, is it the same one? It is the same one. Those dirty rats. I would have been this time. Sample correlation. Oh, this is the R, right? Is that right? That we want sample correlation.
I need to delete everything out of my linear regression thing.
Oh, it is linear regression. Okay. Cool. All right. And delete. Where are we? Delete. There we are. Okay. Right. So we're just putting this in a linear regression, right? So that'd be 7.780. Is that what everyone else has?
I'm still trying to figure out what to do.
Oh,
You have 0.780, right?
testing. 1 2 1 2.
Yeah, can you hear me?
There we go, Mark. You can hear.
Yeah, I'm here. Hey, which one? Which one are we using? So is this a linear regression that we're doing?
Yeah, linear regression because it's the R is what they're asking for. Is my understanding.
Okay, and which one is the explanatory and which one's the response variable?
I do believe it's the same as it was when we did it. So the columns should be the same as they were in the other one.
Okay,
So
so I think
So
response
switch-
then.
14 response, 90 to, and then
So 90 goes first.
I think it's the same. I think it's the same first as we did the other one. So I think we copy and paste from the other one, but I might be wrong.
So I got my R to be 0.780.
Oh,
Yeah, 0.780. I have. Let me double check something really quick. Oh wait, no, 90. No, 90% 14. Is that what we did for the other one?
I don't remember.
Well,
Okay.
the R, well,
90 per, yeah, that is what we did with the other one. 90 first and then the 14. So yeah, that's the same layout. So the 234.19, everything in that column should be on the first column, dependent column, the independent column, and then 14 needs to be the 2.209 needs to be in the dependent column. So, yep, that would be fine. Right.
Luckily, it sounds like it comes out with the same R either way at 0.780. So
Yeah.
we got lucky there.
Oh, I'll take lucky. I like lucky. Okay. And okay. Oh, let's take a look at our little plot. Okay. Is this the one that they already provide for us, right? On this?
Yeah.
Or this is,
Yep.
okay. Or is this, okay, I'm like, make sure. It's that fancy one that we need to do that you are really good doing, Mac. So I said no.
Oh, this doesn't look good.
Everyone got it clumped down the bottom and then a few like shooting up.
Yeah.
Well, so it's semi-linear, but I'm seeing at least 2 outliers.
Yeah.
Yeah.
Hold on. Let me see what are our responses here.
It's either Bravo or Delta. I would go linear, but
That's it. You got
I'd go Bravo or Delta as well.
Bravo. I think. We'll put Bravo and then I'll make a note that either that or Delta. So I'll do Bravo and then I'll do Delta as our thing. Is this 32?
Yeah.
yes.
Yeah.
Okay. Lovely, lovely, lovely. Okay.
All right. So number 33. Let's see, the y-intercept would be 150.640.
So,
Y-intercept. I've got the Y-intercept as what?
Say that again. Sorry.
Thank you. They said they wanted grandma to make a motion. Okay, fine.
so here's my roller. Mark, I've got 33 is 115.640.
That's what I've got too.
Okay. 34 is 0.627.
Hold on. 115. There, and 34 is, oh my gosh, come on, death by, okay, on, and 34, concave inference procedures. I left the slope by 0.627, is that what you said, Becky?
Yes.
Okay. Oh my gosh, this is the quiz that never ends.
$200 is the X value we're doing here. All right, so 240.979 or 240.98. Oh wait, no, 240.
2090, got it. Where are you, devil?
Sir, it's $200. It's $200 flat. It's not 2090.
What? It is 290 for X.
No, it's 200. It's $200 90 days before the flight. It's not 2090.
What? Am I really that dumb? Okay. So do we have all agree it's 24.98?
Yeah, which rounds out to 241 because they only want 1 decimal point, and that would bump the 9 to 0.
Okay, so 241. I hate that for this crap.
241.
241. That's 35, correct?
Yes.
Correct.
241.0. I'm sorry, I fell behind just for a second there. I just
241.0.
Okay.
Yep, 241.0. Got it.
All right. Okay, 95% confidence interval.
Oh my goodness. Just go. Okay.
That's what we've got already, isn't it? Yeah.
Slope.
Yep.
Did you guys? How'd you guys do on the assignment quiz from earlier in the week?
Bad.
I did good. I aced it.
I did really bad, but it was weird. So I got a bunch of my questions were wrong, but like I got both of the confidence intervals questions wrong, but I got the margin of error question right, which shouldn't really be possible.
You, Mark. That's exactly what happened to me. And I was like,
Yeah, I was thinking about emailing Brother Bennett, but he's not super helpful. So
yeah. Same thing for me. It's like, how can my margin of error be correct? But exact same thing. So I took it once and then I went back and switched my columns around, thinking maybe I got it reversed. And both ways, it still didn't work. So I don't know what was up with that.
I got it right when I took it, but I forget done with this. If you guys,
on the same quiz.
after we get done with this, if you guys want to take a moment and get what's the looking for? 36. If you guys want to like look over and see what it like, figure out what it was, I got no problem doing that. But
I'm not that invested.
I was just saying, I'm like, I got it right. I guess like got put a decimal in or something. And he was a mistake, or if there was a mistake and it got fixed, because I might have finished mine this morning.
Maybe.
But he would make an announcement in that case.
On 36, which confidence interval do we use? Do we use the slope, the y-intercept?
The use the slope.
They asked for the slope, yeah.
Yeah, it's always the slope.
0.518.
0.518 for the lower.
Okay.
The 0.725 for the upper.
And was that in the reading, or is that just, does it say it there and I'm missing it here?
It says in the question.
It doesn't
It says it. Right. Confidence interval for the slope. Sorry. Okay. My kids just got home and I've been a little distracted with them. Okay, go ahead. We're good.
Okay.
All right, then I got 0.109 for the margin of error.
Yep.
Yep, me too.
The next 4 questions conduct a hypothesis test to determine if the slope of a true linear regression line is not equal to 0.
So that'd be Bravo.
Yep.
Actually, delta, isn't it?
Oh yeah.
Okay, it is delta. She's right. It is delta. Tons of guns.
I know, because I got that one on the quiz.
Oh. I walked right into that bear trap. Right into it.
Yeah.
They're jerks. That's all. Okay, what is it? Oh, it's not equal to. Okay, so we're doing a not equal to test statistic. Hello, regression. Not that. Okay. Not equal to. There's our test statistic. However you say that is somewhere in here.
Yeah, what are we doing here? Are we still looking at the same information? So
Yeah.
is it 11.510?
Yeah, 11.510.
That's what I got.
Okay.
I thought we were doing different information too, and I was trying to figure out where it was coming from, and I realized, oh, it's just one. are really confusing.
And the p-value is essentially 0.
Yep.
Yep.
Has anyone else noticed that little trend with all of these p-values? Okay. I haven't seen a p-value on one of these yet. That's
Yeah.
yeah. So Charlie is what I've got.
Rejected all.
Charlie for 41. Oh, 42. 42 is Charlie. What was 41 really quick, guys?
41?
What's that?
I got it. Don't worry about it. I just read it down. So, okay. So Charlie, 43.
So, got in the family, 2 boys, 1 girl. And then mom and dad. So,
One sample t-test, I do believe. So beta.
Yeah.
Wait, is that right? Or is it a proportion? No, you're
Yeah, t-test.
t-test. Okay, so it's beta.
It's quantitative.
Mm-hmm.
There you go.
You know, refiner find out how easily gasoline evaporates by measuring its vapor pressure. So they need to determine the vapor high enough. Standard deviation of pressure, yada yada yada. Which hypothesis? One sample Z test.
Oh, nice. Got alpha.
Since we know the standard deviation.
Yep. We're almost there, guys. Almost there. And Trinity wants to know whether the Walmart employees
I'm going to
have.
have to write some things down. So what was the answer for 43?
43 was beta, or Bravo, or banana, or bacon.
Uh-huh.
Beluga.
44 is alpha. And then 45 is test of one proportion, which is way down.
Okay.
It's a test of 2 proportions.
2 proportions, yeah.
Yep. Proportions. And then 47, where are you? I forgot.
Linear regression.
Yeah, the moment you see the word linear in there.
Right.
Yep. Nice.
All right, I'll go ahead and submit this one.
Hey, hold on a second. I'm falling behind. And I really don't need more than 2 chances. Here, wait, give me a second. I skipped one. Ah, that's what it is. 44 is A.
44 is A. Test of one proportion.
Ah, there we
Yes,
go.
Okay.
46 is a test of 2 proportions.
Actually, Mark, have you submitted it already?
Yes.
Mark.
Wait.
7
Have you
is
submitted already?
What? Yes.
What do we do?
It's working on it.
What one, Becky, do you need?
I think I got it. 47 is linear regression.
Yeah.
Yes.
Okay. Thanks. Yeah, it takes it forever.
Oh, we missed one. We missed one. Hang on a second. This is going to take me a bit to find it.
We're so awesome.
Oh, well done, everyone.
So what time are we meeting for the test then?
I know. Amazing.
Actually, I want to. Let me take a look at really
Number
quick.
21.
21. We have down B, correct? So it needs to be delta. That was the one we were debating between B or delta. Bravo or delta.
Is it?
Yep.
Uh-huh.
I am not going back and checking all my answers because I'll get more than one wrong just writing
No,
things down.
yeah,
wrong.
I'm fine with 97.87. I'm good.
Sarah,
I actually do kind of have to get to work.
Sarah, I'll submit this one for us here.
Okay. Make
Now that
sure
we
it's
changed
delta.
that. Yeah.
Okay.
You did see it, Patty? Okay, but you need new numbers? Okay, go upstairs.
No.
No? What?
Let me go make sure it's that one that I missed. Hold on a second.
Okay.
Yeah, so 21 is correct. It was 22 that I missed 22. Well, apparently I did that one wrong. What did we do on 22?
Delta.
Okay. Well, then you are correct on everything.
Okay.
You got
All right.
21 correct though, Matt?
21 delta.
That's 21 delta.
Renegade. Mac went out on his own.
Yeah, right.
He's a loner. He's a rebel.
Okay.
Hang on a second, guys. So I've got the grade sheet up right now, and I don't know that there is actually a final for this class. I think that it's just this last unit test.
Yeah, no,
Right.
that's what we were just talking about. What the?
That would be amazing.
Exciting because I don't want to take 2 more tests. I'm
Well, yeah,
comfortable with 1 more test, but only just.
Will the one test be comprehensive though, or just like, I mean, I know
It's
all the other ones have been comprehensive, but not,
It's to be massively comprehensive, what we just did.
yeah.
Yeah.
That's what I'm, yeah. That's what I don't like.
All right. I'll take it.
Yeah. Okay, so to recap,
All right, guys.
we are
Pause.
working on the PowerPoint presentations, but we're gonna have them all done.
Yeah, we're. I'm going to stop broadcasting.